Welcome everyone. Today we're here to discuss hazardous materials and how they impact your laboratory project. I wanted to start this presentation with a quote, as it's quite relevant to our discussion here today. An ounce of prevention is worth a pound of cure. When I first heard this quote, it was in reference to physical health, but it was actually originally written about fire prevention in the city of Boston specifically. So it really fits our discussion here for today. Ben Franklin had visited Boston in 1773 and was impressed with the fire prevention standards in the city at that time. So when he returned home to Philadelphia, this quote was born as he tried to implore Philly to improve their fire prevention efforts. While this quote is true today as it was then, prevention measures may have small upfront costs, but they pale in comparison to those that result from a lack of preparedness. On that note, as we all know, there's a major push in the laboratory life science space right now, especially here in Massachusetts, where Greater Boston is a top life science cluster. Code and fire officials are also very aware of the influx of life science tenants. With the influx of lab projects comes an increase in lab fire incidents. Fire departments are increasingly concerned with sending their men and women into lab fires with unknown chemical hazards and are starting to reconsider their existing levels of compliance oversight, and they're leaning on building departments to do the same. Building owners and design teams are starting to feel the impact of this shifting environment at initial permitting via comments from building departments regarding new laboratory projects, as well as through requests for additional documentation during the annual permitting process for existing laboratories. This pushback is leading to delays in permitting and occupancy across the state. I've spent a lot of time over the past few months working with life science clients to help them navigate these issues and get their permits on time. And I keep seeing the same things over and over again. While some of my clients are working with us from the beginning of their projects, many people call when they've already received comments from their building permit reviews or during their flammable permit annual license application or renewal process. And that's why we decided to do this presentation today. Hopefully, we can help you understand what's expected from you during the various permitting processes, so you're better prepared to demonstrate compliance for your lab project or facility. We'll talk more about the permitting process later in this presentation, but for now, understand that not being prepared and getting surprised by the code requirements will put your team under a lot of pressure and on a tight timeline. The impacts of these issues can vary depending on the stakeholder. Design teams that are not ready to demonstrate to the building official that they understand and are in compliance with the hazardous material provisions will have to scramble to try and put this together at the last minute. And a lab operator who can't get a flammable permit or maybe another annual certification like Boston's lab registration may not be able to operate their lab until proper documentation can be provided. A building owner or property manager who markets their building as lab ready, but isn't prepared to provide the level of documentation required, risks starting their tenant relationship off on the wrong foot if they can't have the space ready and operating in line with the lease agreement. None of those scenarios even consider the fact that the project may not be able to show compliance. In that case, a whole lot of time and money has been lost. However, all of this is avoidable, as these issues are not new. They've been in the codes for decades, but with the increased focus on life science projects, these issues are in the spotlight across the state and the country, and code and fire officials are starting to enforce the existing code requirements more thoroughly and consistently. The result has been more and more laboratory projects running into issues surrounding permitting. So today we're going to discuss how you can avoid these challenges late in your projects. We'll outline the various permits that need to be applied for and received, and critically, how you can be ready to demonstrate compliance through proper documentation that'll ensure a pain-free permitting process. For you building owners and managers who don't deal with chemicals day to day, we'll see how proper documentation can help you position your building to compete for prospective lab tenants and help you master plan your hazardous material use and storage over the long term. But before we get started, a brief introduction. My name is Andy Shahan. I'm a licensed fire protection engineer, and I work at WB Engineers+Consultants. We are a mechanical, electrical, and plumbing engineering firm. We have offices in Boston as well as nationwide. I'm a code compliance professional by trade. I've been doing that for 18 years. I grew up in Massachusetts, but started my career in California, and hazardous material compliance has been a serious focus in that state for decades. I can tell you that the code requirements vary little from state to state and really haven't changed very much over my career. And this is good news because those of us that have been consulting in this field for a while are already familiar with what's required. We can help you understand what you need to document and how to demonstrate to your code and fire official that you're compliant with the requirements of the code. Applying this knowledge upfront is critical because costs are minimal and there's no impact to your project timeline. Later on, things get much more costly. So first, a little housekeeping. This presentation today is AIA certified for HSW credits, and you'll have a link to a survey at the end to receive your AIA credit, and certificates of completion are available upon request. The learning objectives for this class are to understand why hazardous material compliance is important for a laboratory project, and to explore the responsibilities of both a lab operator as well as a building owner in obtaining these permits. And we're going to understand how the permitting process can be used as a framework to outline code compliance in labs. I don't expect this to go the full hour. There are some technical elements that I'm going to touch on briefly, but I want to keep the presentation fairly high level because the goal here is to help you understand the challenges you're facing from a regulatory standpoint and how to be prepared. And after the webinar, you'll receive a handout with these slides and some more information on everything I'm talking about here. And those slides will have some additional technical detail. Of course, if you have questions on any of this, you can ask them in the chat, as there'll be plenty of time for Q&A after this presentation. Finally, my email address and contact information will be provided at the end of this presentation as well. So you can reach out directly if you don't want to ask it here. Right off the bat, let's define a few terms that you're going to hear today. First, hazardous materials. Hazardous materials are defined by the building or fire codes as chemicals or substances that are physical or health hazards. Physical hazards include things that can lead to fires or explosions, and health hazards are those that can impact human health, such as toxics or corrosives. A control area is another term you're going to hear quite a bit today. Control area is a building or a portion of the building where hazardous materials are allowed to be stored, dispensed, or used. Each control area has what we call a maximum allowable quantity, or MAQ, and that's assigned based on a number of factors. The quantities within each control area cannot exceed the assigned MAQ for that control area. Now, it's important to note your building doesn't need to be designed with a control area because buildings are control areas themselves. One of the keys is to determine how many control areas are in your building, as multiple control areas allow for more chemicals in a building than a single control area would. And these are based on a number of factors that we'll describe later. Maximum allowable quantities, or MAQs, as I said, are code prescribed chemical limits for a control area. And these can't be exceeded without significant fire protection and life safety improvements to the building or that portion of the building. Determining the MAQ is one of the first critical pieces to determining hazardous material compliance. Finally, let's briefly discuss chemical inventory. It's imperative that the tenant understands the chemicals, chemical classifications, the use and storage profiles of their operation to ensure they're compliant with their MAQ. An MAQ is a limit, and your inventory must be shown to be below this limit. For building owners, you're going to need to understand the chemical inventory of your tenants, as you will see when we start to discuss the required building reports. Again, we'll go into more detail on this later on. I just wanted to get these terms defined up front. So why does this matter? Well, we all want to be involved in successful projects. So my goal for today is to help you understand how the building and fire code impacts your lab projects, how the permitting process around laboratories can impact your design and construction schedule, and finally, how you as the building owner or the lab operator can be prepared to deal with these challenges. From a building code perspective, lab projects are classified the same as office projects. This can lead to building departments not even being aware of the hazards that may be present in a lab, and they may just review the space like any other office fit out. Of course, when you're dealing with hazards like those found in laboratories, they're not the same as a typical office fit out. And because of that, the building and fire codes have strict limitations on hazardous materials quantities. These quantities are based on the building's characteristics, not the tenant's needs. The establishment of these limitations, which requires a comprehensive understanding of the building and fire codes, and the documentation needed to prove compliance, are often the biggest hurdles in life science permitting. These limits can be a challenge in any building, even when there's only one chemical user, but it gets really complicated when there are two or more chemical users in a building. And one of the things that surprises building owners and lab tenants who are looking at space is that the hazardous materials limitations in a control area is a zero-sum game. If you're allowed 10 gallons of flammable liquids in a control area, and you give that allowance to a single tenant, the neighboring shell space in your building may not be able to have any flammable liquids. It may be useful as a metaphor to consider other building services, as people are more familiar with these limitations. Everyone that manages a building knows that there are limitations on building services such as power, cooling, water, gas, etc. And they know that they have to either ration it out, or if a tenant requires more than is allotted on their square footage basis, they may require building upgrades to accommodate that tenant. So if power upgrades are needed, for example, the cost of those upgrades must be considered in the lease agreements. For their part, tenants with high power requirements understand that they need a space that can accommodate them. They know to ask for this upfront so they can understand what the building can handle and whether upgrades will be needed. And if it is determined that the building cannot handle them or that upgrades are needed, the costs of these upgrades can be negotiated as part of the lease agreement to determine who will be responsible for them. It's the same with hazardous materials. Every building as it currently stands has a maximum quantity of hazardous materials. As a building owner, if you want to lease your building to lab tenants, you need to understand the maximum and master plan how you allocate these limits to tenants in your building. You need to know if you have a chemical user that will exceed your limits or push your maximums. And there are a few reasons for this. The most straightforward concern is if you have a tenant lined up that exceeds the maximums for their space, is that your tenant may not be able to get the building or fire permits necessary to occupy and operate that lab. If you do not do the requisite master planning, you'll be surprised by this at permitting or occupancy, and the problem may be costly to remediate. If it can be fixed at all, it'll take valuable time when your tenant could be operating and potentially lead to legal issues. If you're a lab operator, you can see how this can impact your business as well. I've never been involved in a project where the tenant was okay with an extended delay between fit out and operation. Especially for a smaller startup company, this type of delay can be devastating. From a master planning perspective, if you as a building owner lease to a tenant with high hazmat needs, without understanding these requirements, you may still end up building out a space that meets the code, and the tenant will get their permits and begin operating, but that tenant may require a significant chunk of your building's maximum allowable quantities. Giving a large percentage of your building's MAQ to a single tenant can hurt your building's viability as a lab building moving forward. Again, think of the power analogy. So this tenant has taken too much of your available power, leaving you with shell space that you cannot rent out to another tenant without building upgrades to accommodate future power needs. However, if you had known about how the tenant would impact your maximum allowable quantity limits to the lease or build out, you could have informed them that they need to include certain building improvements into the design and construction. And this might be as simple as fire rating the demising walls. And that can limit your impact on the building, as well as potentially pass some or all of this cost onto the tenant during their fit out. And at the very least, you and your tenant will have a lease agreement that's comprehensive and detailed regarding these issues. So we've covered why lab operators, as well as building owners and managers, need to understand the hazardous materials in their building. So let's briefly talk about permitting and when you have to demonstrate compliance. I'm not going to go into too much detail here into the mechanisms, but I think it's important to touch all this so you understand the various enforcement mechanisms in place. And then we'll talk about how you can ensure that you're prepared both as a lab operator and a building manager. Let's talk about building permits. This is the first time you'll be required to demonstrate your compliance to a code official. As part of your permit submittal, the Massachusetts State Building Code specifically requires you to provide a report which identifies the maximum expected quantities of each chemical and chemical class. You may have heard the term 414 report mentioned as part of the permitting process. This is a shorthand because they are specifically required under Section 414 of the Building Code. We'll get into detail on these later, but for now, just know that these documents outline and classify the hazards in your lab. They verify your quantities are compliant with the MAQ. These reports are critical to demonstrate to the code official that you have considered the implication of these hazards to your design and have modified your design if necessary to mitigate the hazards presented by these materials. Please understand, these reports are required for all projects involving chemicals, no matter the quantity of chemicals you have. Obviously, a small biology lab will have lower quantities of chemicals than a large chemical laboratory. So these spaces are more likely to be compliant just by their own nature, but the reports are still code required and necessary to prove that compliance to the code official. And it's really important to stress that the fire and code officials cannot do their jobs without these reports, and they take time to create. So do not wait until permitting to get started on this analysis. One key thing to remember is that building permits are only required at the time of construction or renovation, unlike fire permits. Once we've handled the proper documentation and submittals required under the building code, we have to focus on the regulations for hazardous materials that are found in the fire code. Mostly discussed today the procedures under Massachusetts State Fire Code, which is largely an unamended version of NFPA 1, at least when it comes to hazmat compliance. Projects in states that adopt the International Fire Code have all the same concerns regarding documentation, permit, occupancy, and annual inspections that we'll describe here. So tenants using or storing hazardous materials are required to obtain an annual flammables permit with their local fire department. This is used to inform the local fire department that there are hazards in the space that exceed those in a typical office. Remember, the local fire department is the emergency response for fires and other incidents such as spills in laboratories, so providing them with accurate information regarding the hazards they will encounter is paramount. In addition to the obvious concerns regarding fire and explosion, there are toxics and other hazards that our emergency personnel deserve to know about before they run into your laboratory. We'll talk about these issues a little later when we talk about emergency action plans and NFPA 704 hazard diamond signage. Now, we know the building code requires the 414 report. The fire code requires something similar, but calls it by a different name. So you're either going to have to prepare a hazardous materials inventory statement or a hazardous materials management plan. And it's the quantity of chemicals in your space or your building which determine the level of documentation that you must provide. As far as timing, the fire code review does not happen until after your space or building is fully built out and ready to be occupied. If you have missed something in the building code review, or if the building official simply didn't notice that you had hazardous materials in your space and didn't perform such a review, anything that was missed early on can be a real problem at this later stage of the game. But if you did the upfront work required to prepare a proper 414 report, you'll know early on what level of documentation will be needed to satisfy the fire code requirements. You'll be ready, and this process should be smooth. But the fire code official is not done with you yet. So the key thing to note about flammable permits is that they're recurring and must be applied for annually. So even if your project's approved by the building department and the fire department prior to initial occupancy, it's forever required to demonstrate compliance with the original code of record in the fire code. There are annual inspections to renew flammable permits, as well as Boston's lab registration process that must be performed. And I've seen dozens of lab spaces in multiple jurisdictions run into trouble in the past 12 months, and none of them had had such issues previously. And the big reason for this is the shift in enforcement. So please note, while the fire code is the same statewide, enforcement can and does vary from city to city, town to town. So for example, some jurisdictions rely on standard permit forms from the state. The city of Boston has a city-specific annual flammables permit form, while Cambridge uses their online portal. So when you're trying to determine compliance, ask your engineer, code consultant, or reach out to the local fire department to obtain the proper forms and ensure you know what is going to be expected of you. Another example of varying enforcement town to town is the city of Boston's lab registration process that I just mentioned. So this is a citywide requirement that's driven by the city of Boston's municipal code, and it's in addition to the annual flammables permit. This process does not increase the requirements of the fire code, but it is simply a unique enforcement methodology, and it forces tenants, and as a result, building owners and managers, to outline how they comply with the multiple code requirements that govern specific risk to laboratory occupancies. Finally, in Massachusetts, you may have to apply for a flammable license, sometimes referred to as a LAM license. Unlike the flammable permit or lab registration, the flammable license is building specific, not lab specific. So these licenses are only required if your building exceeds totals of any specific hazard chemical quantity that are far in excess of what the building and fire code would regulate. I don't want to go into too much detail here on flammable licenses. If you have a few smaller labs in your building, this may not be a concern, but if you're a building owner with large fuel tanks or large scale refrigeration, heavy chemical users, etc., and you do not have a flammable license, you should look into whether you need one. We'll include the maximums that require those flammable licenses in the handout. So we've addressed why hazardous materials compliance matters and when you'll have to demonstrate compliance. Now I'm going to talk briefly about what has to be done and who has the various responsibilities necessary to demonstrate how you comply. As I described above, the codes have addressed hazardous materials for decades. The challenge that we're seeing now in the state and nationwide is that the enforcement environment is changing. However, with a little bit of advanced planning on the part of the tenant and building owner or manager, you can be ready to demonstrate your compliance with these requirements. In a typical tenant owner situation, this is a collaborative effort. But if you're in a university or a hospital or you own your own building, you're likely responsible for both portions of this analysis. The first layer is the tenant's hazardous material assessment report, or the 414 report we discussed previously. This report outlines the chemical inventory in the tenant's laboratory. That's the principal responsibility for a lab operator, is to have a firm grasp on the chemicals you use and how you plan on using and storing them in your space. Everything in hazardous material compliance starts with an accurate chemical inventory. Now, there may be a motivation to idealize your chemical inventory and not take fluctuations in procurement and throughput into account. But this can be a problem because, as I said, we're talking about annual processes. So if an operator understands the current inventory, they may breeze through the building permit process and their initial inspections. But if this inventory changes over time and you go above your MAQ or your flammable permit limit, it could get flagged during future inspections and cause issues obtaining annual fire permits moving forward. So in a new laboratory design, operators must communicate to their co-consultant about proposed hazards and whether they will be static or if different chemicals and increased quantities may be introduced over time. It's better to be conservative and to have space to grow moving forward. However, understanding the inventory is only the first step to fully demonstrating compliance for your laboratory. And this is where the building owner or manager has their critical role. The building must maintain building-wide 414 reports. At WB, we call these hazardous materials master plans. They're building-focused documents that outline the building's fire ratings, the control area strategy, and the maximum allowable quantities per control area and per tenant. This report also must outline if there's a central chemical storage or waste area, and whether these spaces are considered and designed as high hazard occupancies, which require enhanced fire safety systems. So, for those of you familiar with the NFPA 241 construction safety plans, as the state requires, you likely recognize this layered approach to compliance. The building must maintain their building master report, and each tenant in the building must maintain their own tenant report. The tenants report their information up to the building owner, who coordinates the individual lab inventories and incorporates them into the master plan. Then these reports can be used to track hazards in the building and assign maximum quantities to tenants by outlining and validating the MAQs for the lab tenant as they apply for their building permit, annual permit, or lab registration. Many factors can determine the MAQ for any specific tenant, including the ratings of the floor and structural frame of the building, the number and layout of the existing building control areas, the floor level of the principal tenant we're trying to evaluate, as well as the locations and quantities of other chemical users in the building. The age of the building can also impact overall compliance strategy, as the original building code can come into play. As we mentioned in the tenant section, lab operators looking for space or trying to justify their chemical use in annual permits or for lab registrations must know these limits to confirm they can comply with them and receive their permits. As such, building owners that are trying to attract lab tenants are well served to know all this information and have it readily available. We talked about the similarities between hazmat and electric power earlier. So if you'll allow me another comparison, if you think about MAQ of a specific tenant space as a speed limit, if you're driving down a road without a posted speed limit, you may think you're driving at a safe speed, but you can still get a ticket. Ignorance is not generally considered by the officer as a valid excuse. Building master plans help tenants understand the speed limit so they can avoid costly violations. I like the speed limit metaphor because speed limits are driven by characteristics inherent to the road. So how wide is it? Is it straight or curved? Is it one lane or two? Are there homes and businesses around? And the same thing applies to MAQs. They're specific to the building and the space you're evaluating. So is the structural frame fire rated? Are the floors fire rated? What floor level will the lab be located on? Are there other chemical users in the building? The primary responsibility of the building owner is to identify the limitations inherent to the building and manage their tenants' compliance with these limits. If these limits are not clearly understood, a tenant cannot know the MAQ for their space. If they do not know the limits, they can't know and can't prove to the code official that they're compliant. So this slide represents a simplification of the process. One tenant per floor, one control area per tenant. Each tenant has a limit assigned to it, and the building report compares those limits to the chemical quantities for each tenant. If you're below your limits, you're compliant. The fire official will ask you how you determined your limits, so it's critical that the limits you apply are determined in accordance with the building and fire code, not what has been allowed previously. Excuses like this is what the tenant needs or we've never had a problem before are not viable arguments when the building or fire department is asking for proper documentation. So what happens if this process is not followed? Well, as a tenant, if the building you are looking to occupy has not provided you with a 414 report, how do you know if it can accommodate you? You may find at building permit or occupancy that the building has already exceeded their chemical allowance and simply cannot accommodate you. You may find that you only have a portion of your desired chemical use in your space and that you require chemical storage at a lower level, which may or may not be tenable for your operations. If the building owner does not have a 414 report to submit when requested, the building permit or flammable permit has been delayed as the building owner scrambles to have their building evaluated and document the existing levels of chemicals in their building to demonstrate that the chemical use in the proposed space can work under the MAQ limits. And of course, if it's found out late in the game that the MAQ will be exceeded, that's incredibly painful to all parties. However, even if everything is compliant, the time needed to evaluate existing conditions and prepare the 414 report leads to costly delays prior to the beginning of operations. For you property owners, these reports also serve as master planning documents. They'll help you understand your building limitations. This understanding is critical for a number of reasons. It demonstrates to prospective tenants that you understand their needs and you can accommodate them. It helps you understand your building limitations. Combined with an understanding of your prospective tenants' needs, you'll be better informed during the lease and negotiation process. All the information will be on the table up front. Will you be able to accommodate the tenant in the space they desire? Will this tenant require a significant percentage of your overall chemical allowance and limit your building's ability to accommodate additional lab tenants? Or will additional building improvements be needed, such as a chemical storage room or fire-rated tenant demising walls? It's best to know all this information up front. And it's critical you have someone on your team that's an expert in the building and fire code to make sure all of this is done properly. Finally, while the building code review is primarily focused on construction and fire protection design, the fire code annual permits and inspections require additional documentation to confirm the building is being maintained in compliance with the original design and the fire code. This list is fairly comprehensive of what is required by the fire code for your annual certifications to be maintained on site. Not every fire inspector will look for everything on this list at each inspection, but you are by code required to maintain these items on site and have them readily available. They each outline and demonstrate to the official that you have key safety policies in place and that your life safety systems are operational. Emergency action plans can vary jurisdiction to jurisdiction, but NFPA provides good guidelines on how to perform them This is typically call lists, 24-hour call lists, maybe a map of the space outlining where the flammable cabinets are and other hazards, what to do in a fire emergency. If you have biohazards, you may have doors that you have to ensure are closed, x-rays that may have to be shut off. There's a lot of stuff that goes into those emergency action plans, and they also require drilling and training. So they're a pretty comprehensive document in and of themselves. Chemical hygiene and spill contingency plans. These are probably not going to be reviewed by your code official, but they will want to make sure that they're on site. So make sure if you have an environmental health and safety consultant on board, or if you do it in-house, that you have one of these readily available in your laboratory space. Then your biosafety cabinets, chemical fume hoods, fire extinguishers, all of their tags should be up to date as inspected and operational. All of your fire protection and life safety systems, you should be able to have the most recent test report for your fire alarm, your fire protection, your fire pump. If your building has smoke control or any other fire protection and life safety systems, you should ensure that you have up-to-date tests to demonstrate to the fire official that everything's functioning properly. And finally, SDS sheets, chemical information sheets, need to be readily available for the fire department's review as well. And different jurisdictions have different requirements on whether they want paper and electronic and where they should be located. So make sure you understand the requirements of your individual jurisdiction. Finally, the 704 diamond signage. We've all seen these signs. Chemical classifications of the lab dictate the NFPA 704 diamond signage required on a lab door or space. And this signage is important to responding fire department personnel who run into a space during an emergency. It's a shorthand for what's in there, and they deserve to know what hazards are present in your facility. I sometimes have clients tell me that they just put 4s, which is the highest number, in each of the diamonds to be conservative. But that doesn't help anyone, because the fire department needs to be able to trust this information or it's useless. So too many times I've seen diamonds with 4 in each color, but the lab has been vacant for months or years. It's not okay to simply overstate the hazards, as that may erode trust in the data and delay fire department response. Well, I said it would be less than an hour, so that's it. Before we get to the questions, this is the QR code you can scan, and you can take the follow-up survey if you want your AIA credits, or just to let us know what you thought. This is also the mechanism to get your certificate of completion from the AIA. If QR codes are not something you know how to use, that's fine. You'll receive an email about an hour after we're done here. And additionally, this was all recorded and will be available on our website. And I think you'll receive an email early next week with a link to the recording, as well as the slides and handouts. So that's it for me. I don't think we have any questions in the chat, so I must have done an exemplary job explaining everything. But if anyone has any questions, they can ask them now.
Andy, what is the, how would you approach a building that doesn't know what the tenants are going to be, such as a developer building that is being designed for future life science tenants?
Yeah, so you would want to look, if it's in the state of Massachusetts, there's a few options, but you would want to make sure that you're maximizing your capabilities, right? So if you have, there's a few different strategies. You could do, you'd want to make sure your floors are 2 hours so you can subdivide your control areas on your upper floors, or you can go with 3 hours so you can have high hazard spaces on every floor up the building. So it really depends on what type of user you're targeting and how you want to design that space. But a comprehensive analysis up front, basically creating that 414 report during the design phase of the base building, would let everyone on the design team and the ownership team know what they can expect to put in the space. And that from that information, they'd know what they can get. You know, if you're looking at bio type clients, you probably don't need as many chemicals as if you're targeting chemical users specifically. So there's a lot of options to you, especially upfront new construction. I mean, that's the best time to do this because it really gives you the most versatility over the life of the project.
Thank you.
All right. Oh, I got a couple here. Evaluate an office to a lab conversion. Yes. So I think that's really a critical piece that we're seeing. If you're a building owner and you've been an office building for years, and you want to go to lab conversion, you have to understand that it's more than simply ensuring you have adequate mechanical exhaust and that you have the plumbing fixtures in the right spots. I mean, we have to be thinking about the fire rated construction of the building and how many control areas you'll be able to get based on your existing laboratory design. So if you have a 3-story or 4-story non-rated building, you're not going to be able to subdivide your building into multiple control areas because you don't have the fire rated floors that are necessary to do so. Or you'll have to be very creative, which you actually going above there, but you can do what you can at that point, but there are limitations inherent to your construction. So you just need to understand that you don't want to put a ton of money into a building and find out you have a 7-story building with non-rated floors and you're not going to be able to put anything up on the upper floors of that building. So fume hood exhaust gases. Yeah, so that's an analysis that we as co-consultants work with industrial hygienists and mechanical engineers to determine what the chemicals you're using are and what sort of mechanisms you have to put in place to exhaust them, right? You could have certain chemicals that are going to erode typical ductwork. So you need to design that ductwork in accordance with the chemicals that you'll be putting in it. And then you're looking at what sort of hazards are presented by those chemicals, whether they're an explosion or flammability risk if that exhaust system were to fail. And if that's the case, you need to have more robust mechanical exhaust and electrical backup supplies. So I think you need to just make sure that when you're looking at fume hood exhaust, you're getting all the stakeholders in there that have something to say about it, which, like I said, is an evaluation of the hazard itself and then what it would do to the mechanical systems. Disposal of hazardous materials, regulated by the EPA and the state. So that's not a building or fire code issue, but your environmental health and safety consultant would be able to help you apply for all of the permits and everything that you need to do in that arena. All right. Thank you, everyone, for your time. Thank you very much.